Good morning. It's a nice day in New York City. As usual, I'd say it's a good day for riding the motorcycle. And we'll go up to Hastings on Hudson today for lunch. Now, I have to do a few things in this class. By popular demand, I'm doing more book reviews with a different slant. I'm going to do some of the best written books, some of the worst written books. One of my pet peeves is, as you've heard my previous book review lectures, is having to contend with badly written books. I'll do that after I do one thing first. Now, for the last lecture I gave, Finding the Mass of the Universe, the mass density of the universe, part 2, I forgot to do something. So I'm going to correct that error. I actually have the correction in the little introduction piece, but just formally to remind you what I was doing, I derived this equation by two methods. Okay, the mass density of the universe is given by 3h squared over 8 pi g, where h is Hubble's constant. And it's a dynamical quantity, changes with the evolution of the universe. R dot over r is dr by dt over dr, where this is the radial expansion parameter. Now, so I put in 3, I put in for h, 2.3 by 10 to the power of minus 18 seconds to the minus 1 is h as I worked it out, because h is always quoted, that is Hubble's constant, as being 70 kilometers per second per megaparsec. That's very impractical to be carrying around unless you're a guy with a telescope like this one over here. So if you're just doing SI calculations, kilograms, meters and seconds, the form of it to remember and write it down is very convenient. 2.3 by 10 to the power of minus 18 seconds to the minus 1 is Hubble's constant. So I put that in, we have to square it. We have to divide by 8 pi g. 6.67 by 10 to the power of minus 11 Newton meter squared over kilogram squared. The g, first measured by Henry Cavendish in 1798, is the universal constant of gravitation. I forgot to square this number the last time, so I got a wrong number, but this time I'll square it. This is 36 by 10 to the power of minus 11, because when I bring 11 upstairs it becomes positive 11. Twice 18 is 36. So I get 2 times this squared over 8 pi times 6 divided by 6.67, the whole thing, gives me 9.5 by 10 to the power of minus 27 kilograms per cubic meter. Now minus 27 should hit you in the face. 1.67 by 10 to the power of minus 27 is the mass of a proton. So this is telling me that approximately 6 protons occupy every cubic meter of the universe. Usually they say 1 proton per cubic meter, so my calculation method could be off. Well, I don't think so, right? I think this method of calculating the mass of the universe is more correct, but you know, you can talk to the astronomers about that. So, kilograms per cubic meter is what that should be. Cubic meter. So that's the correction finished. Now let's go talk about the books. I'll leave that there for you to get your heads around. Okay, so what I want to do is remind you about some badly written books, introduce some unexpectedly well-written books, then I want to talk about all the Fireman books. I've got most of them except for 2. Okay, so I've got them here in a stack. As I mentioned before, extremely well-written book is 30 Years That Shook Physics. It's a literary book. What do I mean by that? I mean that the guy who wrote it didn't use 10 words when he could use 2. An example of poor literature to me, poor journalistic literature anyway, is usually the front page of the New York Times. First of all, the front page of the New York Times has very few, although it's gotten better now with our new president. Our new president creates news that they like to print, usually negative. President Trump. There's always something about him, maybe 2 articles, and they could be current. But in the past, the New York Times would have on the front page some item, let's say, to do with something happening in Asia. That's, let's say, could be written 3 months ago, 6 months ago, a year ago. That's, as far as they're concerned, is journalism, but that's not news. Should never be on the front of a newspaper, right? The ordinary standard small tabloids give sometimes better news on their front page. or the Wall Street Journal. Usually has a column of interesting news items on the left-hand side, very quick. Now the other thing is, if you have a title, let's say, major explosion in the Bronx. Let's say that's a headline on the front page of the New York Times. The big flaw, the big mistake that journalists make is they start rambling and writing and writing and rambling, and they have 3 columns written because they want to fill up space, as far as I can see. If you have a headline that says, let's say, major explosion, gas explosion in the Bronx, that should be addressed fully in the first paragraph. You say, in Mott Haven, in the South Bronx, there occurred a gas explosion in a building. Nobody was hurt, but there was considerable damage. That's the first paragraph, right? Then you could add details. But you know, they don't do that. They'll start off rambling like this. Walking down, let's say, such a street, and the weather was fine, and you know, it bothers me. That's poor literature. So, poor journalistic literature anyway. So what is good? Well, nobody can beat, or when it comes to literature, nobody can beat the great man himself, William Shakespeare. Now, so if you're, let's say, not a native English speaker, or even for an audience, even for American readers, because the English is arcane, it might be disturbing. Well, it doesn't bother me. Actually, I like the style. And Shakespeare has the greatest vocabulary, as far as I know, outside, let's say, perhaps of James Joyce, when it comes to writing. He uses, somebody has counted, scholars have counted the number of different words that Shakespeare uses more than anybody else. So, that's an example of a well-written physics book. Physicists are not supposed to be masters of literature, but at least they can learn how to be clear. In his book on quantum physics, nobody, when it comes to writing physics, is clearer than Gasiorowicz. Stephen Gasiorowicz does not fill the pages with unnecessary writings. On the other hand, Eugene Merzbacher does. A very common statement. It is not difficult to show that the following is true. That kind of redundant statement, forget it, you don't need it, right? Rambling and poorly written, this one goes in amongst the ineffective writers. Another book, even though it's a standard work, I don't like it. It's ineffectively written. Rambling English, too much of it. Look at how thick that is. Too much of it, it's not needed. But what is bothersome from this one, for me, is the fact that it's not written chronologically in terms of how things were discovered. Black body radiation, for example, is covered here, but throughout, bits of it all over the place. Boltzmann's equation, way at the back when it should be almost in the first couple of pages. Poorly written. That's Rife, by the way. Rife, Statistical Mechanics and Thermodynamics. Fundamentals of Statistical and Thermal Physics. Sorry, I shouldn't say that correctly. Fundamentals of Statistical and Thermal Physics by Rife is poorly written. And the one I was talking about, Quantum Mechanics, by Eugene Merzbacher, is very aggravatingly poorly written with his rambling statements, redundant statements. Now, my old friend S.J. Gates was very quick in the past to pick up poorly expressed English and redundant statements. And he would make enemies by doing it. There's a famous paper that I worked out of one time that he had with Bellucci and Didier Deperot. What does he say? He said, very often in the literature you see the vacuous statement, he used that word, very biting. He was referring to Mario Tonin and a whole lot of others, and created a huge furore because he was quick to point out the vacuous statement in his own paper. Gates, Grisaro, Rochik and Siegel, by the way, as far as I'm concerned, it's not a particularly well-written book. I tried to learn supersymmetry out of that, and it doesn't really teach you what supersymmetry is. Supersymmetry is actually very simple. Someday I'll give a lecture on it. But it doesn't really begin with telling you what supersymmetry is. You need other books for that. I'm not really reviewing that book. I will also review the books that I have on to do with Fireman and by Fireman. I'm missing 2 books by Fireman. I had them, I read them before. One is Electrodynamics and one is Tuva or Bust. Okay. Now, I want to give you guys a big surprise. Some of the best written and clearly written books in physics, because they are constrained by their publisher to be clear and to hit the nail on the head, are the For Dummies and Demystified books. String Theory Demystified. Quantum Mechanics Demystified, excellently written by David McMahon. Stephen Holzner, Quantum Physics for Dummies, very easy to learn from. David McMahon again, Quantum Field Theory, the guy is top notch. Now these are just other energy and economics, both well-written books. So, a couple of books that I wanted to include that I didn't do the last time would be like, I didn't really give enough account of this. Stephen Weinberg's book, Principle and Applications of General Relativity, is not a book on general relativity, it's a book on cosmology. If I stress that it is a book on cosmology, then it is extremely well written. He has another book, The First 3 Minutes. It was an early success, a very big success in the 1980s. The First 3 Minutes. Somebody asked Stephen Weinberg one time, would he write a book on the first year of the universe, or maybe the first month of the universe? He said, I'll do it in the first 3 minutes. And he wrote a book on the first 3 minutes. But that's covered in here. And he's very mathematically thorough, but the English in it is clear, and the way it's organized is very clear. Stephen Weinberg's great book, the standard work. Expensive though. The other 2 books which I've already mentioned that I regard as being very poorly written are Matthews and Walker, Mathematical Methods. And of course, the worst, Gravitation by Misner, Thorne and Wheeler. There's no need to say all of that. But of course, the best book on mathematical methods in physics and physical sciences by Mary L. Boss. Okay? Smith College has a whole course. Smith College is a women's college in New Hampshire. Has a whole course based on it. It's actually called Mathematical Methods in the Physical Sciences. I was in Princeton one time and I was sitting beside Professor Faraday from Smith College. I don't know if she's still there. She told me about organizing that particular course in Smith College. I really would have loved to have taught it. People don't like Classical Electrodynamics by Jackson because it is hard to read. It is too condensed. This should be made into 3 volumes, really. But if it's stuck in 1 volume, I'll give you an example of how difficult it is to learn from this book. To cover Coulomb's law, they only write down 1 equation. And from there, you have to go and do the problems way back here. The same thing is true when they start doing Green's functions. They don't really tell you how to get what a Green's function is. Okay, they launch into it and it's very condensed. So people get very frustrated with this. Someday, somebody will write a good, let's say, trilogy of books replacing this. As of yet, it has not happened. Okay, so that's Jackson, Electrodynamics, and this is the old version. The old version is far superior to the new thick one. It actually covers relativity much better in here too. The Large-Scale Structure of Space-Time by Hawking and Ellis. Poorly written and full of stuff that you don't really need. The only good thing about it is you learn Penrose diagrams from this. If you want to learn them, this is the book for you. But Tuft teaches them better. Somebody said, will you recommend an optics book? I only have 1 book in optics, and that is the classic by Jenkins and White. All right? It was written in 1937. This one I bought in the street for $10. 1937, was a classic book on optics, Jenkins and White. I would say it's very difficult to get. This was $4.95 when it was first sold. Oh, so maybe I spent $5 on it. I could have. McGraw and Hill, 1937, standard book on optics. Now, since that, many great books have come out on optics, but what's wrong with the early work? The standard of English in that book is wonderful, by the way. For advanced stuff, relativistic quantum mechanics and quantum field theory, which I have, anything by Greiner is extremely well written. It's for the expert, right? Now, the For Dummies and Demystified books are a great start, but when you get into this, now you're becoming an expert, and all the applications of the Dirac equation, they would be in here. I actually haven't gone through it yet, but I know what's in it. I haven't got to the Fireman books yet, but some other books that I like as great reference are as the follows. The Philosopher's Tree, a book on Michael Faraday. It's a biography by Peter Day, and it's wonderful to read. Michael Faraday was one of the great physicists. Without Michael Faraday, we would be without a lot of things. What would we be without? Well, we would great strides in electromagnetic theory. Faraday would have never, if Faraday hadn't done his experimental stuff and intuitive work, he wasn't a mathematician, Maxwell would never have been able to come up with his equations of electromagnetism so quickly. Maxwell was wonderful, by the way. He was one of the great geniuses. I would say ahead of Einstein, or up there with Einstein and Feynman. This is a great person you should have on your shelf, along with 30 Years That Shook Physics. This is Physics from the 19th Century, Michael Faraday. Now, a lot of the quantum field theory that you guys do, in fact, most of quantum field theory, the books that I mentioned, they are field theory at zero temperature. Now, the universe is not at zero temperature. We're at a temperature above absolute zero. Quantum field theory at finite temperature is really where, if you want to look at the universe, that's what you have to get at. This one is by Joe Kapusta, and it's a short book, and it's wonderfully well written. When you get to the stage where you need finite temperature field theory, that's the book for you. Now, I always like this book. I've read it dozens of times. One of the first books I ever had. It's a book of essays by Victor Weisskopf. It's called Physics in the 20th Century, and it's nothing but essays, different ones. I'll give you an example. Survey essays, Fundamental Questions in Physics, The Quantum Ladder, Niels Bohr and the Quantum World, Nuclear Models. Actually, that's one I want to read. Again, I'm going to keep that out because I want to look at it. Two very difficult books, but if you have patience, right, and great tenacity, you can learn Introduction to String Field Theory by Warren Siegel. I like it because it's thin, but you have to get very good at physics to begin learning from that. Polyakov, the master of string theory, string field theory anyway. Gauge Fields and Strings by A.M. Polyakov. Now, this was probably written in Russian and translated. Let me see. I guess not. Doesn't matter anyway. It's a great reference if you're doing strings. Now let's do the Fireman books, or should I keep that for a separate day? I don't know. Let's talk about the Fireman books. Now I have lots of Fireman books. I have, of course, the Fireman lectures, which I've talked about already. Right? Once you know physics quite well, introductory physics, you can start working through these books because they give Feynman's perspective. Like I said, he does not ever make things easy, but he doesn't use many equations either. Feynman never got a cent from writing these books, yet they're some of the best-selling books all over the world. They're published in Russian and Chinese, and they're sold all over the world, and he doesn't get a cent off them. He never did. Fireman and Hibbs, path integrals, quantum mechanics and path integrals. A standard work. There are easier ways to learn the path integral approach to quantum mechanics, but there's nothing to beat reading the man himself, right? But he goes into detail with regard to applications. First couple of chapters is enough to learn the quantum mechanical path integral approach. Now, of course, there is Fineman's book on statistical mechanics. It's a very different approach. But, you know, if you just want to learn statistical mechanics, the first couple of chapters is all you need. Fineman was very good at a lot of applications of all kinds of physics. For example, what did they do? Superhelium. He did work on that too, and some of it is covered in this book. So, another book that he has written is Hadron Interactions by Fineman. It's a little bit out of date nowadays. I like to have it because it's still a classic. Hadron Interactions by R.P. Fineman, written by Fineman. Now, a book that I do not have by Fineman is the one on quantum electrodynamics, QED. I don't mean this one, I mean his more technical book. It's a little book and it's in the same series, Frontiers in Physics. I guess if you went to Amazon.com and looked up all books written by Fireman, it would be in that list. QED, written by Fireman, this one, A Strange Theory of Light and Matter, is taken from popular lectures given somewhere, either in New Zealand or Australia, I can't remember. Yeah, I discussed that before. Non-mathematical, but it gives important insights into quantum electrodynamics. Fineman's Lost Lecture, not a great lecture. It's by David Goodstein, who worked with Fineman. And Goodstein is actually a great writer too, by the way. He has a couple of books of his own. Introductory. He used to do a TV show on Introductory Mechanics. Goodstein. If you could YouTube that, I guess they would be very good. But this is Fineman's Lost Lectures. Most of it is a run-up towards it, and then he deals with finding the law, Kepler's laws, deriving them with only basic principles. Fineman's tips on physics. Actually, I had all these tips down. His method of taking a derivative, I had it already. I was using that when I was at undergraduate level. So the tips in here are not fantastic. I just like to have it because I came across it on the shelf. And of course, surely you're joking, Mr. Fineman. I think this was based on conversations he had with Ralph Layton. I've gone through this lots of times, and I pick it up every so often to have a bit of light reading. Now, the definitive, there are several biographies on Fineman. Let me get one. A good coffee table book is by Christopher Sykes, The Illustrated Richard Fineman, No Ordinary Genius, and it has it has reproductions of a lot of the popular lectures in here, but it also has comments from his sister and from his children and people who knew Fineman. A lot of stuff about Fineman. If you're a Fineman fan, this is a great book to have. Very entertaining. It's best for the photographs. The definitive work and extremely well written. Do you remember I was talking about literature? This is literature, but it's also physics. It's covered with technical details, photographs, and Feynman's actual calculations. By Jagdish Mehra, because he's a great physicist in his own right, but he wrote the definitive book, the biography of Fireman, The Beat of a Different Drum, The Life and Science of Richard Fireman. So it is the life and science, The Beat of a Different Drum, a standard work. I don't know how much it costs, but it was affordable. I just remember that when I bought it. gone through it several times. Actually, it takes a long time to go through that book. It is quite heavy. Heavy in terms of he makes sure to get everything correct. So that's about it for the books. Anything else I would say? I have dozens more books. I'm still meaning to do a book on great papers. Great papers would be very often by Tufte. I like papers by Duff, by the way. So Michael Duff. We'll talk about those another day. Time to take the bike out before it rains. Okay? Till next time.